Hello, geometry students. Welcome to our first video of the year. Y'all should probably be watching this during our first official class period, and then we're going to come back and do a little activity and talk about some stuff some more, maybe answer any questions you guys might have. But y'all should have these notes, and the plan is for you to go through the notes like you would in class. I'm going to write stuff down, and you can choose to write that stuff down if you want or not. And we'll just see how it goes. So our first lesson is really just getting the very basics down so that we have some things we can actually talk about. And there's all these words that we're going to use: point, line, plane, blah, 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 collinear, all these things. We'll talk about these in greater detail as we go, but this is just kind of a preview of all the stuff we're going to be talking about. Just so you guys know, the most basic ones, the ones that we just assume are things without anybody, we don't need any proof of it. They're just things that we say are points, lines, and planes. And we'll talk about each one of these individually in the coming minutes. And like I said before, and I mean, you may not care about this, but these things aren't they're not really defined. They're just these things just are. We just assume that points, lines, and planes are things that exist, and that's really all I need to know about them. So, like I said, not much to write down on this first page, which is good for you. So a point, it's just a dot. You can think of it like a dot. It's not, we draw them like this, here's point A and there's point B, and they're these things, the notation means how do we label them, and you label them with a capital letter. One single capital letter. In this case, it's A and B. P is used a lot, probably because the word point starts with the word P, but it doesn't really matter. And it says they have no size. That means it's not this dot is a millimeter by a millimeter or something, but really the point, the idea of a point is that it's just a location in space and it has no actual size. It's not hugely important. Just understand that points define locations. And every geometric figure we're going to talk about all year they're made up of points. And we're not usually going to think about the points that make up a line or a plane, but we'll think about individual points all the time. So it's important to know that they are represented by a capital letter. We don't use lowercase letters for points because we use lowercase letters for something else. So a line is the next one we're going to talk about, and that is a bunch of points that are all arranged right next to each other in a straight line. And a line, if we just say line, you see these little arrows here at the ends of the line? That little arrow there? That tells you it goes on forever in this direction to the left, and it goes on forever in this direction to the right. And that's when it says extend in two directions without ending. It means that assume it goes on forever, as far as you want it to go, in both directions. And just like with a point, since this line is made up of points, this thing has the line has a length, from A to B is an inch and a half or whatever, but there's no thickness. This thing is it's one dimensional. The only dimension it has, the only thing you can say about it is it's some number of inches or meters or miles long. And the notation for these, and this is kind of important, is there's really two ways to do it. Sometimes we use one lowercase letter. And in this case, that's a kind of a fancy L. It's like an L like that, kind of like a cursive L. And the reason that we use a cursive L is because a print L looks like a 1, so that kind of fancy L. But it can be any lowercase letter. It could be A or B or C or D, whatever you want to choose. In this case, it's L. And that's one way to do it. And the other way is to do it with 2 points. Any 2 points there's only one line you can draw through any 2 points. So I could also call this thing, I could do it with 2 capital letters. In this case, that would be A, B. We could say this is called line L, lowercase l, or you could call it line AB. And this is the part that is going to maybe throw you guys off a little bit at some point because there's going to be more than one of these. But if AB is a line, we indicate that by putting a thing above it with an arrow on both sides. This whole thing here is how we would say line. This means line AB. This means line L. In this picture, line AB and line L are the same thing, but the the double-headed arrow, whatever you want to call that thing, is important because it tells me that you know that this is a line that extends forever in both directions. We're going to see in a minute here that there are other ways, there are other little, I don't know what you want to call this, it's like a hat for the thing. So this hat has an arrow on both sides. We're going to see some other hats in a minute. So we got points, just a dot, represented by a capital letter. We got lines, which is like a whole bunch of points arranged right next to each other, and that's either one lowercase letter, like L, or two capital letters, like AB. And for a line, you got to have the double-headed arrow hat thing on it. Moving right along, the next most important thing is a plane. And a plane is just like, you can imagine it like it's any kind of a flat surface. Top of the table, your floor, a wall, like a big, huge, incredibly large sheet of paper. And planes, like there's no arrows on this, but if it's a plane, you assume that it goes on forever in every direction. So like, it's not just, this plane is not just, these borders here are not actually the borders of the plane. The plane keeps going forever. I think the reason that we don't put arrows is because it's like too complicated to like, where would I draw the arrows if I was going to do that? It would look really weird. So we just, every plane you see is, you can assume it extends as far as you want to, it extends infinitely in all directions. And so it says right here, even though it has no edges, be represented by like this is like a parallelogram or something, but it's like a four-sided shape. And there are two common ways to represent these things notation-wise, like how do we specify this plane? So you can use a single capital letter. So in this case, this would be plane M, and this is plane N, and you can see that M right there tells you that that's the plane. If this was a point M, there'd be like a dot somewhere around it that would tell you that it was a point. Since there's no dot, you assume that that name's the plane. You can also do these things with 3 points, and we're going to see that later. But like any 3 points lie in a single plane, so you could use 3 points to identify this thing. I'll find you an example of that. There'll be an example of that later in the notes, but just know for a plane, which is like just a big flat surface, the usual notation is either a single capital letter, like M or N, or 3 points that all land in that plane. So that's planes. So we got points, lines, planes. If I have like a little piece of a line that ends, like it has these two things, we call them end points because they're the points at the end. It's not just a clever title. We call that a segment. This is a line segment or just a segment, either way. And we label that by calling it segment AC, and A is one endpoint and C is the other endpoint. And that's the only way to mark these things, is by saying it AC. And the notation is this: we write AC, and then so that we know we're not talking about the line that goes through these points, remember that would be a double-headed arrow. A segment, you just put a line over it with no arrows. No arrows for segments. So you can see that segments are like they're like simpler than lines. It starts at A, it goes to C, and it stops. No arrows. That's important. No arrows for segments. So if this was line AC, there'd be an arrow here and an arrow there, but since it's segment AC, there are no arrows. So points, lines, planes. A segment is like a piece of a line, so it's kind of related to lines. This is one that's going to throw people off a little bit. It often does, because the order is kind of important. So That's a little, that arrow's not where it needs to be. So array, it starts at A and it goes, this is called, let's say I'm thinking about array AC. So it starts at A and it goes to C and it goes like, keeps going through C as far as you want. This definition sounds a little confusing, but like basically it's like half of a line. You can think of it like that. It starts like one end it stops at, but the other end it goes on forever. So a line goes on forever in both directions. A segment has two endpoints. It stops on each side. An array is like the in-between. It has stops on one side, but it goes on forever on the other side. The side, like the point where it stops here, A, we call that the endpoint. I mean, there is no endpoint over here. It just goes on forever. The notation for these is this. You write AC, and then you write an arrow like this. This arrow always goes, when we're writing this, it always looks like this arrow in the notation. Even if the ray is going the other direction, you always write the notation like this. So it always looks like AC like this. There's another way to write this ray that's written up here, and you could write it as, you could also write this as ray AP. Because it goes through, and it starts at A, so that's the first point. And then it goes through P, that's the second point, and it goes on forever in that direction. So just so we know, the first letter in this notation is always the end point. And the second letter is like any other point on the array. So we've seen like 3 different hats now. Just so we know, I want to write that over here. If I'm talking about line AB, I would write that like this. If I was talking about segment AB, I would write that like this. If I'm talking about ray AB, I would write that like this. So you see the line has 2 arrows, the segment has no arrows, and the ray has an arrow on the side that goes on forever. The side without the arrow is like, the reason we always write it like this is because it's like A is the endpoint and B is the goes on forever side. So now A and B, they both go on forever. A and B, they're both endpoints. So like the hat is meaningful in some way. So that's what rays are, half a line. Think of it like that. Opposite rays, I'm gonna rewrite those. SR and ST are called opposite rays. They're called opposite rays because they like start at the same point, but they go off in opposite directions. If you like combine these things together, you get a line, right? If you think about this whole thing, it like goes off forever to the left and goes off forever to the right. So they're really, it's really if you add those things together, so to speak, you can't really add these things. It doesn't really make any sense mathematically, but you can imagine combining 2 opposite rays gives you a line. Examples, I don't know, this is like kind of a weird one. Think about like maybe like clock hands. At like at 6 o'clock, you got like the big hand pointing up and the little hand pointing down. That points to 12, that points to 6. That would be one. Anything like that, where there's like 2 arrows going opposite directions, exactly opposite directions, and there's a point in the middle. Those are called opposite rays. I doubt I'm going to use that term a ton, but if I do, now you know what it means. Okay. So here are some kind of important words: collinear and non-collinear. Like this word collinear. You can see right here it has the word line in it, and the word co means like with or together, and line means on a line. So collinear points are points that are all on the same line. That's just the word collinear means on the same line, period. The word non-collinear, you can probably guess. These are points that are not on the same line. And basically, if you look at these points, there's no one line you can draw that'll go through all of them. You could draw a line here, but it's going to go through those two, but it's never going to get to these ones. And I could draw a line here, and it would go through those two, but maybe it would hit that one, but it certainly wouldn't hit that one. And I could draw a line here, and that would go through like these two, but not the other one. So there's a lot of ways to do that. This note is just saying, if I have a bunch of points that are on a line, and then I add one, like I can add 1 point and make this, now I can't draw a line through all the points. So it only takes 1 point that's like screwy to make the whole set not collinear. So again, it's just vocabulary. The word collinear means on the same line, because the word co means like with or together, and the word line is in there, so it means together on the same line. Non-collinear means not that way. I think you guys know the word non means not, so I think I'm good there. And then similarly, the word coplanar and non-coplanar, you can just use the same logic. The word co means with or together, and planar has the word plane in it. So this means points on the same plane. So like imagine like a bunch of dots and a piece of paper. Those would all be coplanar. Non-coplanar points are not points. Points which are not on the same plane. Sometimes people will say the points are in the plane or not in the plane, or they'll say the points are in the same plane, on the same plane. Those things those mean the same thing for our purposes. You don't have to worry about the difference there. I just wanted to say that because I'll sometimes switch. Like I would say these 4 points are in this plane, and I might also say these 4 points are on this plane. I just mean that like they're, I don't know, like they're drawn in the same spot as a plane. Here you can see this point. I'll circle them in blue. These 3 points are all in the pink plane, but they're not in the green one. So these 3 points you would say are coplanar. And not green. And these points I'm circling in red here, those are both in the green plane, and they're coplanar, because I can draw a plane that goes through both of them. But there's no one plane I can draw that's going to go through all 5 of these points. This is kind of an important note just for later on. This is like as close as we can get on a flat piece of paper to draw something that's 3-dimensional. You can see this piece back here, which is like hidden from view, is dashed. So like whenever there's dashes, you assume it's like behind the thing. So this is like 2 boards crossing or something, and the part that's dotted is like, it's like part of the green plane, but it's like behind the pink one. That's what it means when it's dotted like that. So let's see what else we got here. Pretty sure we're gonna get to examples. I want to see probably. Well, let's just keep rolling. Okay. So intersections are where things meet. This here is a picture of 2 things. Line L. Let me rewrite that. I don't know why I wrote that L so fancy. Line L and point A. So this is the intersection of line L and point A. And that intersection, these things meet. Their intersection is going to be a point. That point happens to be A, but anytime you have a line and a point and they meet, they always meet at a point. In this picture, there are 3 things labeled. Line H, line L, and point O. And the intersection of any 2 lines, and maybe you can guess, the intersection of any 2 lines is always going to be a point also. They meet at a point. In this case, the point is O. So I don't think I'll ever use the word cut to describe an intersection. You can see I use the word meet here. But line L and point A intersect or meet at a point, and any 2 lines, L and H, always meet at a point. The only other way you could have two lines is if they're like right on top of each other, like they're just the same line, and then they meet at every point, and that's not that interesting because it's really just one line. Like if I have this line, then I draw another line right on top of it. I guess technically those lines meet everywhere or something, but that's less of a meaningful distinction. So any two lines that aren't the same line will always meet at a point. Yeah, so lines and planes. This is where it gets a little confusing, and it's because it's hard to draw the pictures. This is the kind of thing where if you imagine like a skinny piece of wood and like a piece of paper, it's a little bit easier to think of. There's only three things that can happen with a line and a plane. One of the following must be true. Either the line is in the plane, meaning it's like sitting right in it. Like imagine you like have a piece of paper and you draw a line on it. That line is in the plane of the piece of paper. So like no matter just like that, everything is like two-dimensional there. You could also have this situation where they meet at a point. They intersect at one point. And that's like, if you imagine your like piece of paper with the 3 holes in it, like standard 3-hole punch paper, and you like stuck a pencil through one of the holes, like then it would be like the pencil and the piece of paper are meeting just at the place where the pencil goes through the paper, and it's not in the plane anymore. It's like it just hits it one time. And the other option is this one, and this is like that they never meet. And the word that we use to describe that is we would say that they're parallel, or they're in parallel planes. But like basically imagine you have a piece of paper in front of you, and then you hold your pencil so that it's like parallel to the piece of paper. You can imagine if those things went on forever, they would never meet because like the line stays the same distance above the paper at all times. When we meet after y'all watch this, I have like a little stick I can show you like a little bit better, but hopefully you can imagine what these 3 situations look like. If not, I'll try better to give you guys a demonstration when we meet up in person. So those are the possibilities for planes. So here's just some more pictures of it, I think. So here you can see that this is line K. This line right here, you can see it's labeled with a lowercase letter like we discussed earlier. And this is point P, and this is plane M. So we got line, we got a point, and they're both in this plane. So K and P are in plane M. You could say that plane M contains line K, and you could say that plane M contains point P. So contains means that they're in it. And then here's another line that's going through that plane. Like it only hits it at the one point. So this is like our first situation we talked about on the previous slide. And this is the second one where like it hits it just at one point. And so here's a bunch of things you could say about that I might say. P, point P, is the intersection of this line and that plane. You could say line J intersects, and like these things mean exactly the same thing. And these mean exactly the same thing. It's just saying in a different order, basically. So as long as, the point here is not that you guys memorize all these different ways to say it. It's that when I say these things, you know what I mean. That's the only reason I'm bringing these up. And here's another situation, which is if what happens when 2 planes intersect? Normally you end up with a line. So like when this plane, which is labeled N, and this plane, which is labeled M, intersect, you get this line. That's like everywhere they intersect happens to fall in a straight line. That straight line is called XY. And again, these 4 things are all just different ways to say that when these 2 planes meet, you get this line. And this line is labeled XY. You notice that there's the double arrows. It looks like a segment because there's no arrows in the picture. But like I said before, this plane M, you assume it goes on forever in all directions. And this plane N, you assume it goes on forever in all directions. which means this line is really going to go on forever in all directions. So that's why we know it's a line, and that's why we use the double arrow notation. So that was a lot of things. I'm not going to do this one. We might do this when we come back to class. It's kind of hard to draw these things. So like, I don't want to stress you guys out if you're like, my artistic skills are not good enough for this class. That's not going to be an issue. So we talk about that maybe when we come to class. I did want to do these. These are just some like kind of some simple practice exercises about the stuff we just did. I think it's good for you guys to see me do some examples. So these are two lines here. And just so we have some ideas of ways we can label these things, I could call this one, could call that one line PR, or I could call it line RP, or I could call it PR with a double arrow on it, or I could call it RP with a double arrow on it. For lines, it doesn't matter whether I write P or R first, because it goes on forever in both directions anyways. There's no distinction between P and R. They're just both are things. Similarly, for this line, I could call it line ST, or I could call it ST with a double arrow, or I could call it TS with a double arrow. There's a lot of different ways I could write that. I could also call this line, if I wanted to get creative, I could call it line PQ. You can see Q is right there in the middle. So like PQ, and as long as there's double arrow, it's still going to denote the same line. Or I could call it QP. Right? I write the word line there. I don't have to write this. Or I could call it PQ. There's like three ways to, there's like lots of ways to write this line. And the same thing with the green one. I could call it SQ, or I could call it TQ, or I could call it QT or QS. There's a lot of ways to say it. This says give another name for segment PR. So segment PR is, I'll do it in blue, is this segment right here. It goes from P to R, contains all the points in between them. Another name for that would be RP. Because that still, it starts at R and it ends at P, it has all the points in between it. Hopefully you can see that PR and RP represent the same little piece of this line. Name all rays with endpoint Q. So that means name all the rays where like the point where it stops is Q, and the point, and then it goes on forever in one direction. And where rays go on in just one direction. So one ray would maybe be Q to T. And remember, I gotta use a one-sided arrow for a ray, and the arrow always goes this direction, and I just got to make sure that the end point, the point where it stops, is always first. So this arrow always looks like it's going from left to right, and the first letter I draw has to be the one where it stops. This is not like ray TQ does not have endpoint Q, and it's not the same as this ray. Ray QT goes this way, ray TQ goes that way. So they're opposites. It can also maybe, so that's one ray. I'm going to erase some of this right up here just so we can kind of clean it up a little bit. So ray QT does this. I can also write ray QS. That's a ray with endpoint Q. And I could do the ray that starts at Q and goes through R. I mean, in theory, I can do that if I could figure out a way to make it look reasonable. All right, pretend like that doesn't look all messy. And last but not least, I could do Q. Oh boy. I could do Q to P like that. Nope, I wrote R again. Oh, so I've made at least two mistakes now. That's wrong. So QS starts at Q, goes through S, has to have an arrow here. QR has to have an arrow like this. These all look like that. These all look kind of similar because the endpoint is Q for every one of them. So they all start with Q and then you write the other letter. Which of these are opposite rays? Well, which ones are like opposite, go in opposite directions? QT and QS go in opposite directions. So here's one group of opposite rays. And QR and QP go in opposite directions as well. So those are opposite rays. So in theory, I could ask you questions like this and expect you to know how to do them. That's the reason I want to do these examples, because they're like representative of the kind of things I'm going to ask you to know later. And this is just a kind of a general review. This is the last thing. What are 6 different ways to write the line PR with symbol notation? That's fancy. Fancy way to say that, symbol notation. So one, maybe the first way you might think of is PR, just like that. That's line PR, PR with a double arrow over it. I also know that since it's a line and it goes on in both directions forever, I can just switch the order of those things and it doesn't make any difference. I'm going to do one more of these and then I'm going to let you guys do the last 3, I guess. So I could also do, I could instead of, so PR is this whole line. So what if I started at Q and went to R instead? You could call this thing line QR. So that's the third way. And there's at least 3 more ways to write it. 2 ways to write segment PR. Okay, so segment PR would be this. The other way to write segment PR is to write it as RP. Because it doesn't matter if I talk about the point P and the point R and all the points in between them. I don't care if I start at P and go to R, or start at R and go to P. I'm talking about the same collection of little points on the slide. So for segments, it doesn't matter which order you write them in. For lines, it doesn't matter which order you write them in. But for rays, it does, because a ray has like a direction, a specific direction. Symbol for a ray is like 2 letters with an arrow on top of it, a one-sided arrow. So I don't know, ray QR, you write like that. And that would represent the ray that starts at Q, goes through R, and goes on forever in this direction. And remember, the Q is first because that's where it stops. The R is second because it goes on forever in that direction. So first set of notes, there's a couple of things left in here for you to do, just maybe these. But we'll talk more about this. We'll do some activities. I'll answer any questions you guys might have when you come to class. Thanks for paying attention.